Hello again, Tom from Every Step Physics, EveryStepCalculus.com. This is a physics problem, as you can see, and I put it into the angular acceleration file in the menu, even though you're not finding angular acceleration. You're given angular acceleration and then asked to find what time an object stops. Okay, so I thought I'd put it in there. These are kind of a trick question because number one, the mass of the toy doesn't make any difference, or the train, whatever they give you for mass, is not in the equation. And a couple other things, you know, when you have to change 20.5 RPMs, revolutions per minute, into radians, okay? And I do that for you, of course, in my programs, but you have to do it if you don't have my programs. And once you find the radians, then you take the radians, and that's theta. Theta is equal to the radians, because when you take revolutions per minute, something going around and around and around per minute, you know, and then theta is an angle, you know, like 280 degrees, 90 degrees, 360, that kind of thing. But when you turn it into 2 pi to change this to radians, then you're actually, you know, angular speed, and that's represented by the Greek letter theta. So that's the main thing, and then you take that and divide it by the rads per second squared here, and you come up with the answer. So it's pretty easy. Eliminate the mass, convert the 20.5 RPMs to radians, and if they give you RPS, which is revolutions per second, then you have to change that to radians too, which is just 2 pi times 2 pi. In this case, it's to change it to from minutes to radians, you have to 2 pi divided by 60, which is really pi over 30. So anyways, I show you that. It's kind of hard. It's always these are always easy if you don't if you really study the heck out of it and just sit there and think about it and try to put it into your memory. But in my college thing, I had better things to study. I mean, I couldn't even do it. I couldn't even pass physics. I had to use my programs to get out of that class. And calculus the same way. And I was electronics major. So let's do it here. Physics to get to my main menu. And we're going to look for angular acceleration. And we're going to look for what's given here, which is mass. The cursive A is the abbreviation for angular acceleration, okay? Cursive AC is centripetal acceleration. So this is A, and then you have angular speed, which is revs. But in this case, I wanted to keep going down, and then I put in here just a time as the object stops, because you see when you put this angular acceleration in for your menu, all these things are the variables that you put in the calculator to find angular acceleration. In this case, they give you angular acceleration here. So you're not finding, you're finding time. Well, I could go to the menu here and go down to time, you know, and put this in for the time, but to me it made more sense just to be in angular acceleration. So the time the object stops is what I put it in for. And there's a lot of tests with this in it, so you need to know this, I think, you know. And here I have mass not involved. Give you kind of the instructions of it. We add our variables, pressing alpha first, and for the mass, even though you don't use it, I have to put it in to not throw you guys off. And next one is angular acceleration, minus 2.68, alpha minus 2.68. And revolutions are 20.5, alpha 20.5. And this is RPM, so you have to choose that. We're going to convert it to radians and other formulas, not within angular stuff, but in regular linear stuff. They use revolutions per second in the equations, okay? So we're going to change it to radians. And so here you have the revolutions times pi over 30. It's 2.14168. So I show you these to see if you've entered everything right. I say it's okay, and we do the formula. Here's the formula is theta over angular acceleration. Notice the cursive letter here. I don't know what that's called in Greek, but and you have 2.15 divided by 2.68, so the answer is 0.8 seconds. Pretty neat, huh? Every step. Physics.com. Go to my site, buy my programs. If you feel like subscribing, go ahead and do it, or sharing this to other people in your class or your friends or whatever. Maybe they'll buy the programs too, who knows. And good luck in your classes. Have a good one.